All right, so in this first section of 1.5, we're going to talk about really just some basics of inequalities. A lot of it's going to be a refresher, a little reminder of stuff that you did from Algebra 1. So we're going to do the one step first, and then the next section will be the multi-step. So first thing we need to talk about is the relationship between two numbers. So say you have two numbers, doesn't matter what numbers they are, any numbers at all, one of the following things is going to be true. Either A is less than B, or they could be the same number, and A could be equal to B, or A is greater than B. So we say exactly one is true because it's not possible for any of those two things to be true at the same time. Either a number is less than another number, equal to the other number, or greater than the other number. So these two are our basic inequalities. We also have less than or equal to, as well as greater than or equal to. That will be coming up shortly. The first thing we're talking about is this property of inequality that we have right here, the addition and subtraction property of equality, and it looks something like this. If you have an inequality like this, if you add the same number or subtract the same number from both sides, it doesn't change the truth of the inequality. So it looks something like this. Start with addition. So let's do an example just using less than, and then just know that it'll be the same for greater than, or less than or equal to, or greater than or equal to. So then this is true. Or this is true. So it's saying if we know that this is true, if you add the same thing to both sides or subtract the same thing from both sides, it's not going to change the answer. All right, so I'll write it for greater than, just so I don't throw you off. So if A starts off being greater than B, the exact same thing will hold. I can add the same thing to both sides or subtract the same thing from both sides, and the inequality won't change. So A plus C would still be greater than B plus C, or A minus C would still be greater than B minus C. Okay, so here's a really good example I want you to think of. Say like me and you, whoever you are, say that either I have more money than you, or say that you have more money than me. Not overall in our accounts, just say like in our hands. If someone takes away $5 from both of us, whoever has more is still the same. Or say someone gives $5 to both of us, whoever has more is still the same. Say I start off with 20 and you start off with 25. If someone takes 5 away from us, then I have 15 and you have 20, you still have more than me. So adding or subtracting, as long as it's the same on both sides, doesn't change the less than or equal. It doesn't change the less than or the greater than. Okay, so just to review, we're going to write down a couple of inequality symbols here and kind of what they mean. Should be straightforward, you should remember it, but just in case. Okay, so this one right here is greater than. This one is less than. Some people have seen these symbols a million times, yet they still mix them up, so we might as well just write them down. I've always remembered this one by thinking it kind of looks like a crunched up L for less than. And then this one, if you throw the little line underneath, and this is greater than or equal to. So this is like half of an equal sign down here, and then this one is less than or equal to. Might not be a review that you need. Maybe you know those super well, but I'm sure there are at least a couple of you that needed that. Okay, so this example, we are going to solve this inequality and then graph. So we're going to do a little review of how to graph on a number line as well. So this process basically works the same as solving equations. We're still trying to get the variable by itself on one side. So let's start by subtracting 4y from both sides. Okay, just because the 5y is bigger, doing this way kind of saves us from dealing with any negative variables. So here I have a negative 3. Make sure you keep the negative in front of it. And then less than 5y minus 4y gives me y. And then plus 2. So the next thing I'm going to do is I'm going to subtract the 2 from both sides so that I can get the y by itself. Okay, so this will cancel. So negative 3 minus 2 gives me negative 5, which is less than y. So if we say that negative 5 is less than y, if we read it in reverse order, what that actually means is that y is greater than negative 5. So if negative 5 is the smaller of the two, that means that y is the greater of the two. So normally you want to write it like this. So this is your answer if you're writing it out in symbols. We also want to see it drawn out as a graph. Okay, so start with a number line. And now I am not going to get fancy at all about what you need to put on the number line. I don't need you to actually write like -5, -4, -3, -2. I don't need that at all. All I want to see is the 0. I want to see the 0 on there. So a lot of times people just put the 0 right in the middle. And then make sure that this number appears on the correct side of 0. So -5 would be over here. So again, that's really all I need to see. I need to see the number in question, and I want to see where it relates to the 0. So what you do is you start with a circle. There's going to be a circle on this number. It's either going to be an open circle or a closed circle. So let me write down here just as kind of a reminder, and then we'll graph it. So a review. A circle, or I guess we could say an open circle. So like this is used for a less than or a greater than. And then a closed circle so like this, actually shaded in, you'd use that for less than or equal to or greater than or equal to. So basically, if -5 is what you're supposed to be bigger than, it's not actually going to be equal to -5. So we want to mark the -5 on our number line because it's an important number. We just don't fill in the circle because it couldn't be equal to -5. All right, and then greater than means any number greater than -5. Greater than means you shade to the right. Okay, so it's going to look something like this. And then I usually kind of shade the arrow too, just to show that it keeps on going forever in both directions. Okay, so anything that's bigger than -5 is now shaded here, but the -5 itself is not circled in because it's not included in my inequality. All right, so it looked like that. Make sure you write this down for a little reminder for yourself because we're going to carry that on through the rest of this section. Okay, next, multiplication and division. Now, addition and subtraction is super, super easy. Multiplication and division have slightly more complicated rules. So as long as you're talking about a positive number, nothing changes. So we can start by saying if A was less than B, if you multiply or divide by a positive number, nothing changes. So you can multiply by a positive number and nothing changes, or you can divide by a positive number and nothing changes. Okay, or really quickly, let's write the scenario if A started off being greater than. Again, you can multiply by a positive number and nothing changes, or you can divide by a positive number and nothing changes. Okay, now here is a rule that I'm sure you guys remember. If you divide by something negative, or if you multiply by something negative, the symbol will switch. Okay, so if A started off being less than B and you multiply by a negative number, the inequality will flip. If you divide by a negative number, the inequality will flip. This is a super, super, super important rule. If you multiply or divide by a negative number, the inequality will flip. Okay, so say A starts off being greater than B. If you multiply by a negative number, the inequality will flip. Or if you divide by a negative number, the inequality will flip. So think about this. Let's go back to the money example. Say that I have $20 and you have $25. You're in the better scenario. You would have the greater than. Say we flip those to negative numbers. Say I'm $20 in debt and you're $25 in debt. -20 compared to -25. I'm in the better scenario now. I have the greater. So if you switch them to be negative, or you multiply them by a -1, the inequality actually switches. You go from being in the better scenario, then if we switch it to debt, I'm in the better scenario. Okay, last little example here. We're trying to get P by itself. So what we do here is we divide both sides by this -0.3. Okay, so the -0.3 will cancel here. We divided by a negative number. So we know for sure that this inequality is going to flip. Okay, it went from being greater than or equal to, it is now less than or equal to. And I know I have the P by itself right here. Here's a little trick for dividing by decimals. First of all, I have a positive divided by a negative, so I know it's going to be negative. 12 divided by 3 would be 4. So 12 divided by 0.3, and I would end up with 40. Okay, so you move the decimal, but in the opposite way that you would normally do it. So if you are normally multiplying by a decimal, you would move the decimal to the right, but since you're dividing by a decimal, I'm sorry, I just mixed up my signs. If you're multiplying by a decimal, you would move the decimal to the left. If you are multiplying, you move it to the right. So 12 divided by 3 is 4, but since I'm dividing by 0.3, I move the decimal over 1, and I get 40. Okay, so this, remember, if I want to write it in the opposite order, p would be greater than or equal to a negative 40. Now graph the solution on a number line. So set up your number line. Remember, I always want to see the 0. You can use that as kind of a middle mark. Negative 40 would, of course, be somewhere to the left because it's a negative number. I have an or equal to. Since I have an or equal to, that means the negative 40 is included in my set, and so I shade it in. And then greater always shades to the right. Less than shades to the left, greater than shades to the right, because these are all the numbers that are bigger than a negative 40. Okay, so that would be your final answer. Okay, in the second half of 1.5, we're going to deal with the more complicated inequalities where you've got, addition and subtraction as well as multiplication or division. Okay, so this first example right here, we are trying to get just an x by itself on one side of the inequality. That is your end goal. So basically, you just want to kind of look around and see what seems to be causing the most mayhem? What seems to be making it the most complicated? And I would say that it's this 5 in the denominator. That seems to be making one of the sides really complicated. So remember, you go for the opposite. We're being divided by 5, so you multiply by 5. You multiply this side by 5, and what happens is the division and the multiplication cancel each other out, but then you have to take the left-hand side and multiply it by 5. So let's recap. If we look up here, we are multiplying by a positive number, so our inequalities do not change. So it still stays less than or equal to. If you multiply or divide by a negative, then your inequality would flip. So I have 5 times negative 3x, and that gives me a negative 15x. And then my right-hand side is now much simpler. I just have the negative 4x plus 22. Okay, so next, remember, like I said, we want to try to get all the x's on one side. So I'm going to take this guy and I'm going to move it over to the left. So it's a negative 4x. The opposite would be a positive 4x. So whatever I do to the right, I do to the left to keep the balance. So these guys will cancel each other out. I have a negative 15x and a positive 4x. That leaves me with negative 11x. My symbol hasn't changed because addition does not change the symbol ever. And then I have 22. And then the last thing I'm going to do is get the x by itself. It's currently being multiplied by a negative 11, so the opposite would be to divide it by negative 11. Now be super careful here because this falls into this category. I am dividing by a negative number, so dividing by a negative number will flip my sign. So this is now a greater than or equal to. If this has the or equal to, so does this. That part will never change. And then all I have left is the x, and 22 divided by a negative 11 gives me a negative 2. So that's my answer in inequality form. I'm just going to graph it. So start with the 0. Negative 2 is over here to the left, where the negative numbers go. It's greater than or equal to, so since it has the or equal to, I'm going to shade in my circle. And then greater than means I shade to the right. Okay. Next one, we've got some distribution to do here. So the negative 5 gets distributed. Now, since I'm not doing anything back and forth, this negative doesn't affect anything. As long as you're simplifying things within one side, it's not going to mess with the inequality. So I distribute the negative 5, so I get negative 15d, and then negative 5 times negative 7 is a positive 35. Greater than, I haven't done anything that would change that symbol yet. Distribute the 3. 3 times 2d is 6d. And then 3 times positive 14 is positive 42. Okay, so next comes the addition and subtraction. Remember, I want to try to get the variables on one side and then the numbers on one side. I'm going to do this kind of all in one step. It's easier for my inequalities just to get the variable on the left, so I'm going to do that. So I'm going to move this 60 over by subtracting it from the right and from the left. So this cancels. Now I still have a number on the left-hand side that I want to move to the right-hand side. So I'm going to subtract this 35 from the left, and then I balance by subtracting it from the right. So now I have no more constants on the left. They're all on the right, and I have no more variables on the right because they're all on the left. So simplify this down. Negative 15d minus 60 leaves me with a negative 21d. is greater than, and then I can subtract this right here, and I end up with 7. Okay, so now I want to get the d by itself, so I'm going to divide both sides by a negative 21. And again, be super, super careful. I'm dividing by a negative. When I divide by a negative, my symbol will flip every single time. So these cancel, and the d is now by itself. And then be careful here. A lot of people will want to tell me this is negative 3. It's not. The numerator is smaller, so it ends up being negative 1 over 3. Because these both have a 7, and I can reduce it down. So I get a negative 1/3. So again, this is my answer in inequality form. And let's graph on a number line. So show me the 0. Negative 1/3 is going to be like just barely to the left of it. Just a little bit negative. My symbol is less than. There's no or equal to, so I'm going to leave an open circle. And then for the first time, we're actually shading to the left here. So less than are all the numbers to the left. I always shade that arrow too to show that it goes on forever. Okay, so that's the second part of example 3. We've got one more example. This one's kind of an application problem. So Javier has $15 to spend today. So at most $15. That kind of starts to sound like an inequality problem. He buys a bag of pretzels and a bottle of juice for $1.59. If gasoline costs $2.89, how many gallons can Javier buy? Okay, so here's what we know. He definitely spent $1.59. And then he also wants to buy gasoline for $2.89 per gallon. So he could spend $2.89 per gallon. So I'm going to use a G for the variable. So however many gallons he gets, he just multiplies it by 2.89. And then we add on to that what we already know that he spent on food. Okay, it says he has at most $15. Okay, so this, what he's spending, it seems weird, but our symbol's actually going to be a less than, because what he's spending has to be less than what he has. He can't spend more than what he has. And then it's always a tricky question like, do I have the or equal to? Do I not have the or equal to? So he has at most $15 to spend. He could spend exactly $15 if the money worked out well like that. So we do have the or equal to, and then we've got $15 right here. So our goal, when he says how many gallons of gasoline, we're trying to solve for G. So really similar steps to what we just did on the previous examples. We want to start by subtracting $1.59. Okay, so cancels here. We still have 289 G is less than or equal to. Okay, so when we subtract this, some of these decimals, I'm going to be okay with some of this work being done in your calculator. So we do 15 minus $1.59. So he's got $13.41 left for gas. So if you think about this in the context, what this means is he started with $15, he bought the pretzels and juice, and this is how much he has left for gas. So then if you divide by the price per gallon, that'll tell you how many gallons he can get. Okay, so you're dividing by a positive number, so the inequality won't change. So let's divide this. So 13.41, we want to divide by $2.89 to see how many gallons he can get. So the directions say round to the nearest tenth, so we're going to do 4.6. And since it's a story problem and there are units, you want to make sure that you include the units. So that would be your answer. He can get up to 4.6 gallons with the amount of money that he has left, but no more.